program lead for WIT. I'm also a principal engineer in Chief Technology and Architecture Office here at Cisco. Before I introduce our speaker, I just want to give a big shout out to WISE, Women in Science and Engineering Group. I don't know how many of you know, but this program is actually a program under WISE. And the WISE leadership has been supporting the program since the very beginning. They helped me get started. They come in and volunteer. They are not here today because they're mostly in Grace Hopper Celebration Conference, I believe. And they also sponsored today's lunch, so I just wanted to acknowledge their help for us. Thank you, guys. Okay, so we're going to talk about containers today, the new shining knight of the whole virtualization technology. And if you look at any developer conferences, what's happening in that space, containers and microservices are talked about a lot. And it's very important for us to understand, be familiar with the vocabulary, but understand the technology a little bit. So our guest speaker, Vipin Jain, is an expert in this area. He's the founder and the lead developer for the project Conti, which is an open source project working in the container infrastructure policies area. Vipin also worked on the ASICs for the UCS platform that we have, ACI and Nexus, so he has a wide range of experience. He told me that he would like all of us to get as much as possible from this session, so please do ask your questions throughout, especially the stupid ones, because we learn from them the most, so don't hesitate. The only thing is that your questions cannot be heard on WebEx unless you speak to your microphone, so I'll try to hand you the microphone, otherwise Vipin will repeat your question. So with that, I'd like to get started. Vipin?
Thanks. Can someone pass me the ball so I can share my presentation? Got it. Okay. All right. Before we start, I want to, is my voice heard on WebEx? Can someone confirm that? Is my voice okay, heard on WebEx? Great. Okay, cool. I want to poll everyone into not making it boring, but at the same time, interesting enough that you go back and do some things on this on your own. How many people have actually played with containers here? 3, 4, 5. Okay, maybe about 10% people or 5% people. Not bad. I will try to make sure it is more engaging for you guys too. But at the same time, how many people have just heard about containers but haven't dig deeper into it? Okay, the majority. Okay, so what I'll do is let's make it interactive. I don't have many slides. You can see on the side there are about 12 slides, including the thank you slide, and the first one is just the first. So there are 10 slides overall. I expect it to be super interactive and lots of questions. At the same time, if there are things that you want to check back with me, here's my email, and you can hit me on GitHub or any place else. So with that, I thought that let's talk about why is this disruption big? I mean, why is so much buzz about it? I mean, the kind of buzz that is there with containers is equivalent to, or probably more, in some cases exaggerated, but more than what it was with VMs. Why is that so? And why is it bigger, better, or is it like too much hype that we are looking at? Personally, I've used containers in practice and have seen the benefits. So I would vouch that benefits are real. There is a little bit of exaggeration going on with respect to what it can promise to do versus not. So let's start off with very simple thing as to what really containers are. Containers are virtualization for operating system. I want you guys to just think about it. Every slide, I want you guys to think about it and sink in the concepts at a little bit higher level first. So we all run applications on an operating system. There are hardly few applications that don't run on operating systems. Even tiny IoT application which is running on something is Raspberry Pi is running some operating system. So you have applications that are running on inside an operating system. What containers do is they allow you to make you think that you are running on your own operating system, but actually there is not one operating system given to each application. So if I have, in this case, 2 applications running, then 2 applications think that they have their own version of operating system, but actually there is only one operating system underneath here. So why is that important? We'll talk about it. But most importantly, it's very different from what VMs are, is what I want to emphasize. VM gives you an infrastructure as a service abstraction, which means it gives you a unique operating system for every single virtual machine. And that's quite different from containers here. How do you create the illusion of an operating system? It's you are made to believe that you are sitting in your own office, but actually you are sharing it with so many other people. I mean, so the way you do that is what concepts called Linux namespaces. So a namespace is effectively giving you a way to make believe that the process ID space or whatever a process thinks about is actually unique to, give me just a second, is actually unique to your process or your application. So we'll run a couple of containers, we'll see how that looks like and see how it looks like from inside an application. So think of what an application sees from an operating system. If you can emulate that, if you can simulate that, or if you can make it believe to an application that you have got your own process ID space, you have got your own version of operating system, you have got your own root file name spaces, for example. So which means as an application, I can go muck around with anything in that and still will not disturb the underlying operating system, which is right here. That's the fundamental reason, or that's the fundamental mechanics of creating an illusion of an operating system. And then, so because of that, you can run containers in a VM. There's no as such conflict that containers and VM are competing from each other and all that. But at the same time, it is true that you will run better if you don't run it on VMs because of performance gains and other things. We'll talk about that. In order to run an application inside an operating system, what I say that containers have done is, you guys all play, MP3 music, correct? Well, my computer restarted. Okay. But I know the presentation, so I'll just talk through it. So so if you were to run applications within an operating system, then the illusion that is given to you that you're running on your own is, hold on a second, I need to log in and everything. Okay. Okay. I would say that. Yeah, no, it's my computer. It crashed. It was behaving, I think. I guess I ran too many containers on it. Okay. I am connected to internet. That's good. I want to make sure I'm connected to WebEx. And we all think that Windows is buggy. Okay, so how do I think I have to go back to the WebEx link. It's connecting to WebEx. Okay. Yeah, it's connecting to WebEx. Yeah, I'll share it just in a second. Okay. Okay, can you see it now? Okay, awesome. Let me attempt to run the presentation mode. No, it doesn't work. Okay, rewind back to first slide. So going back to my original point that applications need to see that this is what their runtime environment is, and in order to create that, there are a lot of tools, LXC and some of the technologies like namespaces, control groups. They have been existing for a very long time. But in summary, it gives an illusion to an application that you are given your own operating system, and application B is given its own operating system. But why would you want to do that and not share it? And then we'll get back to the gains that you have with these applications. So I was going to the point of, people have been using music. The industry before MP3 came out versus after is so clearly, starkly different. And why is it different? If you just go back and reflect on why did MP3 change the music industry? It's probably because standardization of format. Applications didn't have a format before. And that's what containers are doing. Once you standardize the format of an application, what you can do with and how you can port it, and what your MP3, let's say, once the music person creates the MP3, it can run on MP3, on your phone, to your big, music system, to you can port it, you can listen it on Spotify. There are all kinds of possibility opens up because of the standardization that occurs with defining how music should be encoded without losing the context in which and what it should do, regardless of where it runs. So that's what containers have done to applications. The standardization of format, which is what really containers did to the actual shipping industry, that's how containers, is that once the size of the container and the hooks and everything was standardized, people could take that container, put it on a ship, put it on a train, put it on bus, put it on truck, wherever you want. What you keep inside is your business, but the way it gets transported is decoupled from what is inside that. That's the main power of standardizing an application. And with that, if you standardize an application, what impact it has is what I want to get to, is it changes the way applications are architected, developed, built, run, tested, scaled, tuned, and upgraded and monitored and everything. If applications, because now I have a unit that I can take it in the way I want to run it anywhere in my data center or in my network or in my IoT device, and we'll do that experiment shortly, but we'll build a container on a Linux system and I'll try to run it on my Mac. Let's see, whether it successfully runs or not. But the portability of an application and the application unit is fundamentally changing, and which is why I think the entire life cycle of an application is fundamentally changing. If it changes the application life cycle, now guess what? Anything under that has to change too, and which is why I think the disruption is as big as anything that has happened in the past. About if the fundamental unit of application is changing, then all the ecosystem entities that runs underneath. I mean, let's be honest about the fact that the reason our compute and everything exists is because we need to run applications. So if applications change, then what all changes underneath can go from the whole gamut of things. So, companies like Cisco, Dell, EMC, NetApp, Hewlett-Packard, they are in the physical infrastructure business. This layer has to react to, how these things percolate down. Let's go from top down. First of all, once you define the application images, how you store, how you retrieve applications, that changes. Exactly. I'll draw parallels to music industry quite often here, but the way you are retrieving your music and how you're playing is now different because of that standardization, because of the way you can store things, because of the way you can port it, because of the way you can take in USB and do various things with it. Same thing with applications. Now there are stores, there are images that you'll upload your applications to these stores, and you download it. You can create marketplace for applications, which really didn't exist, because what's the marketplace for applications if you don't even have a standard way of defining what an application is? So that's what containers do, which is changing the way how applications get delivered. And there are companies like in Amazon, Google, they have trusted registries which you can use to download these, certified, validated applications. If you want to run MySQL application, there is a certified version of it available on these application store, and the images are, curated with respect to that they're secure or they're safe and doesn't contain any harm, vulnerabilities and things like that. Those image stores, or what people call registries, are becoming into existence because of that change that happened to the applications. Next layer, we will peel down, one layer at a time. The middleware, how people used to use Ansible Chef. I don't know if people are familiar with Ansible Chef. So, those are the tools to configure, run applications on the servers. There is a big disruption in that industry. They're trying to find their purpose now, honestly, some of them, and some of them are reacting to it and trying to make it more relevant for these applications. So there are companies whose existence is questioned because of this movement, and it is rightfully so for the ease of use and all that these tools were created. But without an application format, these tools were still relying on some consistency which is provided by the infrastructure and not by the application developer himself. Once, as a developer, I build an application, I can say that this is what my application should look like and this is how it should behave. But it doesn't matter where it runs and how it runs. It should be like that, which means that the way it takes configuration, the way it should be run and the way it should scale is not decided by some outside tool, but I have to be able to define a lot of those parameters as a developer. How do I say that this application runs and how it takes configuration and all that? That is getting standardized. So all the middleware layer, like monitoring systems to configuration management to workflow management for these applications, they are getting disrupted, and rightfully so, because ultimately the tools were created to solve a complex problem. But if the problem is solved fundamentally by defining, standardizing, and the format of the application, then you don't need to solve it exactly this way. I'm not saying these are not the challenges right now in containers, but they are being addressed in a very different way compared to how things are today. So there is disruption in the middleware layer, which offers way to run applications. IBMs of the world, people who are running, WebLogic, WebSphere type of middleware systems to various things. The amount of logos that I can put wouldn't fit here, honestly. I just try to pick few that will give a flavor of what impact it is having on the middleware infrastructure companies. If you are familiar with any of these companies, they are in business of fine-tuning, finding out the performance of applications, monitoring applications, and knowing exactly what is happening to an application. But without standard format of an application, can you really do that? Well, you can try to do that. So I can do this thing for Java application. I can do this thing for XYZ type of application. So it does change and has a lot of impact on the middleware software which is being run across in the data centers. I'm focusing on data center, but these things are applicable beyond that to IoT and other things. But I'll keep the talk on the data center. So there is that impact which is happening right now. And having used it to a level, I feel that maybe some of the tools are not even relevant or not even useful. So because of the way you're defining the fundamental unit of running compute, the way I see containers is not that these are like you package the application, but this becomes a fundamental way to run to use compute resources. That's your currency. What maybe that's the right word, is that containers are the new currency. Whenever I talk to you about something, we exchange using dollars or whatever the currency is, because we know that language is common between us. If the currency of application is containers, then that becomes a standard unit for a person who's talking about security versus a monitoring versus developer who's developing the application versus an ops person who's running that application is responsible for uptime of that. So all tooling that he uses for that needs to shuffle, needs to change. So there is disruption happening at that layer. Orchestration, rightfully so. I didn't put VMware in the orchestration layer because VMware is still orchestrating heavily VMs. They are actually also orchestrating containers, but inside VMs right now. I would say that the tooling that is coming out with respect to what Kubernetes does, or with respect to what Mesos does, or what HashiCorp's Nomad scheduler does, or Docker Swarm scheduler does, is the amount of, the dynamic nature of scheduling application is what is needed to run application scheduling. So let's differentiate between application scheduling from VM scheduling. Two very different things. Application comes up in a matter of seconds, goes down whenever not needed. On the other hand, VMs largely stays for at least a couple of hours, if not for days, maybe months sometimes, but at least it stays for a couple of hours. You don't start a VM and 2 minutes later you tear it down. The reason is because you provisioned a VM to run applications. You can't run applications if VM is not up and running, which means the life of a VM, the scale of VM is very different. So the challenges for an orchestration layer, which is trying to run these applications in a very dynamic way, are very different. You cannot take the same paradigm that was applicable for VMs to be used for containers anymore, because in the previous slide we talked about it changes the way people are architecting applications. I am kind of burying the comment that microservices are becoming more real with containers, because you can architect an application that can spin up and scale out and scale in depending on the demand of the resources, demand of the applications that it needs to. So if applications are getting architected like microservices, then you need to run those microservices and schedule those microservices very differently than you are scheduling VMs, or you are scheduling any resource for that matter. I don't want to take on VMs, but ultimately, it is changing the way applications are scheduled and orchestration is done with that. So new players are coming out. A big disruption there with respect to how the scheduling and orchestration for these applications happen. Few that I know of that I've played with, at least three, four of them, actually all four of them we have played with, is a promise that we can schedule your application in a very different way. And I'll talk about that, what the challenges are too here and in upcoming slides. But that layer is shaking a bit with respect to what was used before is not even applicable, or even if it is applicable, it doesn't suffice to the level of agility and scale that is needed for container applications.
We have a question on Webex.
Sure.
Can you explain more service discovery layer?
Yeah, I'm getting there. Okay, yes, right in time. You typically, what do you do to discover VMs? Let me throw that angle at the question. I mean, VM is identified using its IP address and you SSH into it, or domain name that you can go and log into a VM and all that. If imagine that on one server I was able to, and honestly I was running a lot of containers on this Mac. I don't know if it went down because of it, probably not, but I could actually I was able to run 1,000 containers on a host. Now imagine you are having just one rack of servers, which can potentially have anywhere from 20 to 40 servers, and you're talking about 8,000 containers. It's quite high, honestly. I don't think people will go totally crazy and run 8,000 containers in one rack. But how do you discover those things? How do you find out that this is this application that I try to run as my development application, or that so-and-so application is fourth instantiation of the web server that I wanted to run? This challenge of trying to discover each other, like let's say at an application level, at abstract level, I don't want to talk about IP addresses. I know we are Cisco, and a lot of people here are Cisco, maybe some are not, but we all love IP addresses. V6 even better. But ultimately, do applications care about that? Probably not. What they care about is that as an application which is implementing a web tier to run some logic that is interfacing with the end user, that's my presentation layer, I want to talk to my application logic. So all they care about is the indirection that they should be comfortable defining, saying that I don't care where it runs, I don't care what IP it gets, I don't care what port it uses, and I don't care which machine it runs on. As long as I can say that I want to talk this application, I'm good. So the requirement for discovering who's offering what service and then be able to connect to that application is what service discovery layer provides. And tools like Console, Zookeeper, etcd, they're popping up to give some solutions there where you can, in a distributed systems, start discovering the roles and the roles and the functions of these applications that you can dynamically discover I emphasize dynamic because it cannot be that someone goes and punches this in. The need for automation, the need for complete integration with application language is super important here, and I'll talk about challenges. But one of the things which is happening about this is how applications are discovered and how they are interconnected, or how they communicate with each other, and how they do function in a distributed way. Microservices and distributed applications are, to me, same things. The world is becoming more from monolithic applications to, we hear about this, oh, world is changing, monoliths are bad, and we are going scale out distributed applications. But what happens in a distributed application is what service discovery solves. You have 10 instances of a service which is running. You can be connected to any one of the backends for that service. Can you honestly not worry about what networking is needed, what storage is needed, what infrastructure is needed, and be able to say that, I want to connect to this application, and then someone tells you that, okay, to connect to this application, this is how you should do it. And that is all hidden underneath the infrastructure, software infrastructure layer, that then can make it simple for application developers and application people to deploy these applications. And keep in mind the scale, because scale and speed, those two things are going to really kill this thing if you don't have these tooling in there. So that layer is changing quite dramatically. Things that used to be static, or things that used to be done like in a scripted way, I wouldn't call it static. People were not running static things even before, but they were using their own homegrown custom tools. It's becoming more and more well-defined and standardized now. Again, going back to my point that if you define the fundamental unit of running an application to be standardized, then you can standardize everything underneath. Otherwise, it's all custom here or there. Not that some toolings didn't exist, but people are using their own ways of getting it. So I can say there are about 50 to 100 startups in containers area. I'm not highlighting all of them here, but my point is that the shift in building this infrastructure is so big that the investment community is believing that this is the way of predictably and meaningfully deploying applications, and in which case these layers need to adapt to what application needs, as opposed to reversing and forcing it to be used in whatever way you want to offer. So first four layers are really software high level ops type of layers that are having that shift, the disruption that I'm talking about. Container runtime, we all have heard about Docker, but there is an initiative in the Linux Foundation called Open Container Initiative, which was originally run by people from CoreOS who did Rocket runtime. Runtime is like, as long as I know MPT format, I can run it in anywhere, in any way I want. Docker doesn't have to be a way I run a containerized application. So people are defining the runtimes in a couple of ways. So I would say probably Docker and OCI are the most competing standards. Docker engine is different from Docker runtime. I want to clarify that a little bit, because Docker engine can also run OCI container images. So these are container formats or the application formats, and then who can run what application format is the runtime for that application format. So that layer is quite dramatically changing, or I would say it's getting created. It's not even there. It was not even there before. Operating system layer we all thought was like Linux is it and all, but there are at least a couple of startups that have popped up in defining the new operating system to just run containers. So if you think that the disruption is not happening all the way to Red Hats of the world and Ubuntu and Canonical and these companies, it's not true. They are seeing the impact of this. Why? Question is, why should operating system change? I mean, I was running application before, I can run application now. The number one thing that people who deploy operating systems today, and their biggest worry is that, what if there is some vulnerability in the OS? How do I upgrade it? Because if I'm running libassl or certain certain images or certain OS image which has been discovered with vulnerability, and I can upgrade it because there are some applications that are running that depend on that distro or that version of an operating system. I cannot upgrade the operating system. But if I package all that into application, which is a container, then I can argue that you don't need a big operating system. All you need for operating system to do is one thing and one thing, which is to run container images efficiently. That's all. So as a result, a couple of companies like CoreOS and even Red Hat has spun up a project called Project Atomic. It's open source operating system to just run container applications. Same thing, with VMware working on Photon OS and Ubuntu, and they have their own versions of, container optimized operating system. Because you don't need anything else from operating system. A kernel, let's go back to the previous diagram. You need a kernel. When I say operating system, you need kernel, the IO type of facilities that a kernel gives, which is file systems and networking, basic file systems and networking and those things. What else do you need? You don't need lots of versions of Python or packaging that goes along with distributions of Linux kernel, which means what I need is a bare minimum small kernel and a way to run container applications. And as long as I can do that, I can package all the application dependency inside the container, as opposed to keeping it in the operating system, which is what prevents us from upgrading the operating systems at the speed at which we want to upgrade, but we can't because we are kind of bounded by applications that are using certain versions of libraries on operating systems. So it is shifting how operating system industry is evolving itself, because of that. Virtual infrastructure people, you can say that almost all of them have embraced containers now. Talk about AWS, talk about Microsoft Azure, Google Cloud Platform, VMware, OpenStack. All the VM layer provider or the infrastructure as a service provider are actually embracing this way of providing virtual infrastructure which is tuned and more suitable to run containers as well. And then physical infrastructure vendors like Cisco is a great example. How can we make it better for applications? At the end of it, it's not a turf war here. Everyone in the stack is trying to see how can they make applications run better, faster, scalable, in most efficient way. So can something be done in anything, for example, that Cisco does or HP does or NetApp does, to how storage gets access, to how networking gets accessed by those applications? We talk about scale, maybe that's one of the challenges anyways. Yeah, question? Actual adoption of containers itself is not that high, I'll tell you at this point.
Can you repeat the question?
Yeah. The question was, what is the adoption from containers point of view? What is the adoption by virtual infrastructure players? Correct. If I were to paraphrase the question, there are two ways they are adopting it. The first one is because they are threatened. Second way is because they are trying to embrace it because they see value in it. Percentage adoption of containers is probably going to be a 2 to 5 year cycle. I don't think it's overnight, event. Nothing happens overnight. But the way they are adopting, for example, if I were to take AWS, if anyone has tried AWS, you can go to AWS and get a VM. Now AWS offers ECS service, which is EC2 container service. You don't need to get a VM. You just tell them what application you want to run. So with that, now you can run applications natively on AWS without worrying about getting VMs and all that. Same thing with Google Cloud Platform. They're giving you a way to run applications. So the consumption of infrastructure is moving up a little and saying that don't worry about VMs, don't worry about servers. We don't want you to think about servers anyways. So if you want to run applications, just submit your applications, we'll run it for you. If it is a web application that needs to expose itself out, we'll do that. If it needs to load balance, we'll do that. So the cloud guys are offering native container services by what I call embracing it. Whereas, people who are not cloud, like on-premise, like VMware and all that, they're also giving you the same service of running containers natively, but alongside VMs. And that's the strength that they are bringing in. Because like I said, the transition is a long transition. So in which case, if the transition is not very quick, how do you make it work with applications that don't run on containers today, or that are not containerized, or that you don't want to containerize for whatever reason? How do you have them coexist? And that's the part, that's how VMware and other people are embracing, including OpenStack. Was there a question? Yeah. Yeah, I think I'll repeat the question. I think the question was that, what is the impact on security with respect to this, and especially if you were to run an application in AWS, is it more or less secure relatively, right? The biggest worry I would say at this point with containers is security, and I'm glad you brought it up because let's go back to that picture, right? If you are sharing an operating system, then your biggest worry is if an application breaks out for some reason, let's say, how can it not damage other application? Let's say I give root access to certain application. Can it go and hamper other applications from running? Can it do more damage? And more importantly, can it get access to the data of other applications? So I'll split the question into two parts. The first one is when you are a multi-tenant application provider service, let's say like ECS or Google or cloud providers or service providers. For them, they are today, as of today, they are not running containers natively alongside belonging to two tenants on the same machine. So they create the virtual machines underneath for you. You don't have to worry about it. But at the same time, VM gives a PCI level abstraction, which is machine abstraction, and then they give you that complete security there. On the other hand, if you are an enterprise user, there are cases where applications are all owned by you. They're trusted applications. Your bigger worry is not that it can be saying they don't have work for that, but you are still having complete control over it because you own those applications. So if me owning the application and providing you the same infrastructure is different from me owning the infrastructure and someone else's application that I want to run. So those are the two variations there. The approaches in those two methods are different. If I were to take Twitter, Box, some of these companies, they run containers on bare metal. They don't run it on VMs. Why? They have like one application, maybe Box has two applications, one to store and everything. So doesn't mean that what if something is compromised, doesn't mean it can percolate down there, but they don't worry too much about it because they own the application, they own the infrastructure. So people who are trying to get the max out of it, like Twitter and maybe Apple and these guys, they are actually running applications without VMs. But cloud providers give you these container environments to run inside VMs. So that's the way right now security is being solved. There are many references I could give you, like for example SecComp or SPP, and people are trying to think of, again, security needs to be application level too. What is application level security? Can I even talk to you as a different application? How do I know I can talk to you, and how do I authenticate with you as an application? And that's the kind of things people are solving at application level security as we speak. There are a couple of startups I know working on it. We can talk about it. I don't want to advertise them right now, but it is a challenge. Like, let's start thinking everything in terms of applications now, and truly application sense way. If I'm talking about security between two applications, then how can I ensure that these two applications are indeed allowed to talk to each other and they're authenticating with each other as two applications and not that not otherwise. So that's the level of security people are thinking about. So it doesn't matter what goes underneath. Even if something were to get compromised, all data could be encrypted or both in transit on and rest. Any questions?
Two questions on WebEx.
Yeah.
The first one is, isn't it better to use a container that's portable across cloud provider versus AWS specific or Google specific containers?
Okay, I don't need to repeat that question because you're on mic, right? Okay. Portability of containers. In fact, I say this is the strength of containers. What you run for containers on-premise is exactly same as you run on cloud. The container image doesn't have to change. Going back to MP3 analogy, it doesn't have to change. So you are running not only the exact same application, but people are standardizing the interface that you run those applications as too. There are two interfaces right now that are popular. I'm sure people will try to customize it and all that. There's Docker interface and there's Kubernetes interface. There may be other interfaces like Mesos interface that is aligning to that. But the application itself doesn't change, or the way it behaves, it doesn't change whether it is run in cloud versus not.
The second question is, What value do containers bring for high-performance data plane functions? High-performance data plane functions can be routing, encoding, encryption, etc. Or are containers primarily for lightweight control plane-like applications?
I know that Netflix is using containers, so I will outright say that it is for high-performance applications as much as it is for lightweight web applications. So in that case, how you use that and how you maximize that, I'm sure that Netflix is spinning up a container every time you're trying to stream something for every user, and if I were to guess that, but in that case, video streaming is as high performance need as it could be. So I wouldn't differentiate that it is only for one versus the other. The first part of the question, which was like high performance functions that are needed, that really doesn't belong in containers. It belongs in the infrastructure which is needed for containers. So I'll talk about some of the challenges that we need to solve to get there. Is that a question? Because it is a very standardized way. Think about, like, let's say I want to write an application that can stream video to a user. I need 4 parameters to it. What's the user ID? What is what kind of service that user is paid for? Maybe is paid for little or higher. Based on that configuration parameters, I have a lot of compute where I can start streaming this out from. But where do I do that? So container schedulers provide a way to pick the best available machine to start doing that. That's one thing. Second is, as an application developer writer on Netflix, if I were to do it, I don't have to think about how it's going to get scheduled and where it will get scheduled. I can write one application which I can test on my laptop and say that if I can stream from this application out, then it should work elsewhere too. So defining that format is another reason they are actually embracing containers. A lot of tooling is coming for free. Honestly, that is a big reason too, because Google is throwing out what they found in Borg. Borg was their predecessor to Kubernetes. Think of Borg as the scheduler that schedules billions of containers for Google over the period of like 4 or 5 years. They have spun up so many containers using Borg scheduler, and those are the guys who started writing Kubernetes and open sourced it and threw it out. Why would you not want to use that kind of sophisticated tooling? So if they get hands on tooling like that, they would definitely use it and deploy it to run for thousands, millions of subscribers that they want to handle across data center, across geography, across regions, to be able to cater to that instantly, because these schedulers actually give you a way to run these things on demand and then take it out when you don't need it. So that's the key reason. I think we are getting into the benefits part, which I will talk about. Is the question? Very good question. I think the question was, what does it take to containerize a legacy application? If an application can run on Linux, likely you have Linux or Windows, likely you have a chance that it could be containerized. The main reason, the fundamental reason why it cannot be containerized is how closer it is to the lower layers and hardware. And if I'm using some special purpose things that are provided by certain hardware and all that, becomes difficult to containerize it because the abstraction becomes lower and lower. To give you an example, there are like, I don't know, there are like hundreds of thousands of applications that people have containerized and uploaded it on the registries that I talked about. On the other hand, I did containerize, people who have worked on data center next operating system, I did containerize the entire build process for creating an access image into a container. So maybe it gives you a flavor that you can. I mean, if you have used any build machines on Cisco, typically you would go and acquire a machine and you would just run your compilation there. It has lots of toolings. It's called Vegas Build Environment, VBE. But what we did was we containerized all that inside. We kept all that inside a container. We supply the code to the container, and code spews out a binary. And having done that, we got rid of the VMs and deployed all our build tooling and build machines and all that to use containers, which means that with 20 servers that we were using before, which goes back into the benefits of containerization, is the scale and efficiency. What we were betting on was that earlier we would give every developer a VM that has maybe 8 cores, because you need at least 8 cores to compile that size of binaries and link them. So with that, instead of giving 4 VMs from every server out to 80 developers from 20 machines, we scrapped the VMs and we said that every time you need to compile something, we'll give you instead of 8 cores, we'll give you 32 cores, because that's what was available on every server. And with 32 cores, your compilation is 4 times fast. Actually, it's more than 4 times fast, because if you give lot more memory, it's faster. So with that, we were just betting that at a time, no more than 20 people are compiling, which was a reasonable assumption. And with that, we reduced our compilation times by 1/5 right then and there, which goes back into scale efficiency. Also, to give you a flavor of what all can be containerized, going back to your question on why legacy applications cannot be containerized. In some cases, you may not containerize an application if if you are running on systems that require a certain specific type of either I/O requirements or NIC cards that you need to have access to, or potentially they are. I know that applications that have been containerized, the size of container is not a challenge. You can have a 10 gig container and who cares less. So the APIs that you need and the operating system on which you are running, because Docker, to run the container engine itself, you need certain version of kernel and all that. Hopefully everything is backward compatible, but if you are running on a very old archaic version of Linux or Windows, which is not compatible with Windows 2016 or not compatible with Linux 3.1 onwards, maybe you cannot containerize those things. So overall, the benefits include you get a very consistent application delivery. That's the biggest, by far the most appealing to the application developers, because as a developer, I don't need to go and debug a problem for you to deploy my application, and that didn't work because of your problem. I mean, when I say your problem, you're an ops guy and I'm a dev, and we could do DevOps type of role, in which case I myself have to go and fix it if it were to not work. So that's the biggest benefit. Deployment agility is another big benefit. You can truly embrace microservices. You can do replication for various services, scale out the loads, restart upon failures. All that is built into schedulers. When people talk about when Amazon is rewriting their next version of their web applications, it doesn't get delivered to every user. They just test it on 1% of the people. You need a scheduler that can give you that capability to say that these 1%, put them in the test mode. Sure, they may or may not work, but at least scheduler needs to have a capability to say that roll out this newer version for 1% of users. If it works, I'll increase that and dial it higher to 100% over the period of maybe month or maybe week. So that is the that is the benefit for from deployment agility and all that point of view. Question?
2 questions on the WebEx. One is, if the application requires a dedicated IP address, is it configured on the OS at the time of orchestrating the container for that application? Where is it configured? And then the other one is, how many containers can be supported on a single instance of OS?
Yeah, I think when I tried, I'll answer the second question first, which is, you can easily go 1,000. There is no limit that I ran into beyond 1,000. My take is that 1,024, I ran into a limit because of some OS. It was a minor issue with respect to number of NetDev interfaces that could be created on an OS, but I think it's been fixed in the latest kernel version. I don't think the number of containers is a challenge. The challenge is the amount of CPU you have on that operating system. To answer the first question on, can we give an IP address to a container? Yes, we can, absolutely. I wanted to actually show it live, and by spinning up a container and see how it looks like from inside out, and just play with it a little bit to see. But yes, you can. I think there are many solutions, including Contiv, that does that.
Maybe we can move on to that.
Yeah.
Before
okay, we have 10 more minutes to go. So I would say that scale, efficiency, deployment agility, and to better characterize applications, you can be very accurate on what is happening to the application. You can deduct that, you can monitor it very clearly, and provide application level visibility and all that. So in all summary, data center is in transition, whether we like it or not. VMs are changing the containers, scale up applications are becoming scale out. Monitoring, instead of monitoring, you're doing active tuning to applications, so there is never like downtime as such. From monoliths, you're going to microservices. Scheduled release is no more a thing. You are always on continuous release, and instead of running application always, you are running it when you need it, and you terminate when you don't. So that has implication in infrastructure. What used to be, physical virtual machine management is going to become immutable infrastructure management, where you don't care about, how many instances and where they are running. You treat them mostly as an opaque set of things that you are running. SDN overlays need to become application centric in a very meaningful way, like providing an IP for container and giving the native DNS discovery for every applications and all that. Storage needs to be, instead of, needs to be very software defined. The way containers consume storage is really based on volumes that can map into it. So there are challenges. The benefits are to part extent also challenges. In my case, there are opportunities, honestly, because if things are developing now, this is the time to strike it big and make relevance to how this could be leveraged by others and be useful, when trying to solve some of these challenges. So scale is a challenge. You need to embrace declarative intent model. You need to embrace distribution to be able to solve that. If I'm running 20,000 containers, if I'm managing every single container one at a time, something is wrong. I'm not doing it right. I need to be able to tell what do I need from the orchestration system. It's like, I need 20 instances of this application, doesn't matter what. It should be able to figure out where things are running and not that. If I cannot run that, if I cannot admit that application, I should reject it before it gets accepted. So instead of trying to deal with individual applications, you are dealing with an intent of what you need. You don't have to define how it needs to be done, but the model of defining what you need is what is taking gain and taking a lot of relevance into scaling these things. Because in scale model, you don't try to manage every little thing yourself. Instead, you say that this is what I need. Go figure out what is needed to achieve that what I need. And so you describe what you need, not how it is needed. For speed is a challenge. To be able to handle that, we need to automate things. We need to make sure that the models we are using ourselves are scale out, which means the infrastructure we are writing, can it scale out? Or if I'm writing one single monolith entity to manage all these containers, then I have not embraced these methodologies myself. So all the infrastructure elements that we talked about themselves need to be not only automated but also provide a very good scale out model. They need to be microservices themselves, except that they happen to cater to the infrastructure microservices as opposed to the actual applications. We are creating more layers. That's true. There's a physical layer, there's infrastructure layer, and then there is VM layer, and now you have container layer. Are we improving, or are we creating more complex things? And usually the cycle is that you make things worse first before you go down, but it doesn't have to be that way. Containers do provide a very simple, flattened way of, high performance way of consuming the infrastructure, which in my personal experience has been quite tremendous gains from the speed and the efficiency. Also, these challenges that everything needs to become application centric. Someone asked a question on the security. How can security be application centric? Can an application authenticate other application? Can network be application centric? Can I say that what doesn't matter what IP I give you, you should be discoverable natively as an application. Every application should have an identity in the network. So network, storage, compute, service discovery, security, everything needs to become application centric. That's a challenge, but there are ways to do it. With application format getting defined, the next thing that you need to define is the entire blueprint of an application, which consists of multiple applications that you run together as one. And the application is not always just one binary that is running. It consists of multiple tiers of applications that you need to run together as a wholesome unit. Either you run it on cloud or in a laptop or in data center. So it needs to be integrated. It needs to be integrated with that definition of blueprint of an application, so that you can port it at that level as opposed to at an individual container level. So that's what is the challenge, but people are working on defining that. Shared resources is a challenge I talked about. You have these applications that are running side by side. How do you guarantee that? How do you guarantee that one cannot DOS attack another one? You got to make sure that resource isolation and all that is very well handled, and not only very well handled, but also guaranteed. Because if you don't provide the guarantee, then someone is going to spin up one cluster for application A, another cluster for application B, and things like that. Hybrid cloud is a challenge. You need to be consistent. What you run in public cloud, private cloud needs to look exactly similar. Security was a challenge that was brought up. How do you isolate things? How do you isolate tenants? How do you provide the resource isolation to those things? Telemetry and diagnostics. the bigger challenge there is scale and speed again, because that's what makes it even worse. You having to monitor 5 machines is very different from you monitoring 20,000 applications, and you have no idea what's going where. But it needs to abstract out to the level where you can talk in the terms of you try to give the intent to run an application. You should be able to consume the telemetry exactly that way. So if I spun up this application, you should be able to tell me what is happening to that application. I see some people smiling. Maybe they've worked on something like that, or they've run into a challenge there. Okay, so just 2 minutes on Contiv. This is an open source project. It allows, it solves some of these challenges to define, to provide a way to consume, along with these schedulers, a way to consume infrastructure, which includes storage and networking, and compute in the best possible way. It has a UI, which could be CLI or REST-based, GUI, but it has a distribution that goes along with it. The components that Contiv has are themselves Scaleout components, so you can spin up any one of them and you can kill any one of them and restart it. It will recover itself. That's the goal and principles we followed trying to build Contiv. It is integrated with physical infrastructure as well, so that you can give the best out of physical infrastructure to the applications. Maybe I have certain capabilities that I can leverage for certain applications for video transcoding that that is available. You paid for it. The gear is already there, but how can you leverage that for containers? So very high level picture. I'll be happy to talk about it. If you just Google Contiv, you will hit the GitHub page, and you're more than welcome to actually contribute to it in your spare time or play with it. I'll leave you with a pointer to tutorial to play with it. There are 4 components to it. It provides networking, storage, clustering, and UI. Connectivity, security, load balancing, visibility, prioritization on the networking side. Of course, performance scale is important, as someone was asking. For storage, persistent storage for applications that are still not microservices, you need that to be able to provide that. Provide the allocation policies and what kind of snapshotting you need and disk management. And garbage collection of pools. You are spinning up so many containers, and those volumes are getting spurred. And how do you reclaim that back? Again, you cannot reclaim a volume at a time. So you need a policy to say that for these applications, we can reclaim my storage and volumes at certain period and certain intervals and doing that, right? So cluster is to do the node lifecycle management, and UI is the way a user exercises this at the cluster level. So with that, I don't know whether we have time. I wanted to actually go live with this, but let me take a note of 0. Okay. There is a github.com Jen tutorial. If you go and it will take you probably 1 hour to. I'll just highlight that. Not here. Where's my web page link? Here. So this is the tutorial. Let me increase the size of this. Once you download this stuff, it has a way to clean up everything once you are done playing with it. But it gives you step-by-step way to actually play with containers and and take a look at what happens inside containers, and then I'm also describing some of the concepts here. But the reason I created this was because there were too many things going on, and I felt that maybe someone who doesn't know anything about containers, and if someone follows this verbatim, can they get a taste of containers on their own laptops? So you don't need to acquire some big machine or something like that. And look at container networking specifically for that matter, but you can run almost any experiment in containers that you want to do here. So check it out. Yeah, just Google Jen Vipin tutorial, or you go to github.com/JenVipin/tutorial. Next, I will. If time permits, we can do a couple of live things on my laptop, but I don't want to squeeze it.
Yeah, thanks. I just want to say, I know some people have to leave at 1, and I don't want to take extra time, but if there is an interest, maybe you can come back and we can have a session where we're actually playing with the container.
Live stuff, no presentation.
Just the live stuff. If there is an interest, I can arrange another session quickly, and we can do that. I just want to thank Vipin for coming here and sharing today.
Thanks.
And thank you all. Next month, there's going to be a panel discussion about how to stay on top of the technical advancements. And then I'm going to send out a survey. If you can fill it out, that would be great. I really find that useful. And share it.
Feel free to connect with me. I'm more than happy to engage. If you have any questions or if anything I could help. Great. Thanks. Thanks. If it didn't crash, I would have squeezed another 5 minutes. I think so.